scientists working at the South Pole have been looking in the sky to find the remnants left by inflation. These scientists claim that they have found the most compelling evidence yet that the universe went through a faster-than-light expansion in its early moments. So basically, our universe is known to be started off by the Big Bang Theory. The observable universe emerged from an incredibly small, incredibly dense space, probably due to some quantum processes, and then it slowly expanded out through time. And of course, the oldest light in the sky is the famous cosmic microwave background, or CMB. And this indicated that the event occurred about 13.8 billion years ago. Then, astronomer Edwin Hubble showed us that galaxies are rushing away from us, from each other, from everything around us. Everything is expanding away. But it is simply the space between the galaxies, not the galaxies themselves, that seem to be expanding. And if you look further back in time, you see that the galaxies are receding back even faster. Run the universe backwards through a simulation, and everything must be at a closer point, closer together in the past. Scientists themselves theorize that if you go further back in time, the more difficult the physics is, and it's harder to describe and comprehend. Some theories to understand these certain physics in the past are gravitational waves. This would put a distinctive twist pattern on the polarization of the CMB. So basically, how does inflation fit in? Well, basically, it's a way of describing the expansion of the universe at a trillionth of a trillionth of a trillionth of a second after the observable universe came into existence. And this universe, our universe, went through a rapid super expansion. One of the pioneers in inflationary cosmology theory is American physicist Alan Guth. He describes inflation as a sort of bang within the Big Bang. And this inflationary theory has been proven mathematically to fix the puzzling problems and aspects of the Big Bang Theory. For example, it explains why the universe looks so smooth on greater scales, and it also explains the structure that we see within the universe. The random quantum fluctuations that existed before inflation would be amplified to provide the seeds for everything that came after. So inflationary theory is a very hard theory to prove. So basically, what are scientists doing to prove this theory is correct? Well, it has been theorized that the very rapid expansion would be amplified by these waves of gravitational energy. And these ripples of gravitational energy through the fabric of space-time would leave a unique mark on the CMB. Gravitational waves, alternatively, squeeze and stretch space as it passes through it. And the primordial waves associated with inflation would likely to have changed the orientation of the oldest light in the universe. In other words, it would have polarized the light. So basically, they are looking for some kind of gravitational influence in the radiation just after the Big Bang. This being the case, it should be possible to detect the very characteristic twist in the CMB. This is provided that the signal is large enough and the instrumentation is sensitive enough to detect it. This is already going on, and it operates of a project called BICEP2. And BICEP2 stands for Background Imaging of Cosmic Extragalactic Polarization 2. So yeah. So basically, if BICEP2 can confirm this theory, what does this exactly mean? It represents our most direct detection of gravitational waves to date. It is a huge step in the study of the origin of the universe. Inflation has always involved some highly speculative physics, very controversial and very hard to understand mathematically. The size and shape of the signal claimed by BICEP2 means that more exotic models and theories can be struck off, and we can concentrate on the main theories of the origin of the universe. And most importantly, this discovery could give scientists the energy scale of inflation. the physics that they developed to describe inflation must now fit into that parameter of the energy scale. This is also good news for the energies implied by Bicep 2. They are consistent with the ideas of the grand unified theory. This could be in the realm of particle physicists that believe that all the fundamental forces in the universe, in nature, can be tied together. Particle physicists are asking similar questions using giant particle accelerometers like the Large Hadron Collider. And that is a basic description of what inflation is, what it can do, and how scientists are trying to detect it and understand it, mathematically and in nature. Thank you for watching, and this is our universe, and keep discovering.